build a spacesuit. We're still a bunch of years off.
The inside, I'll get to the outside. Dr. Lee, you ready?
Yes, sir.
When they aren't participating in the habitat simulation,
Got it?
scientists here are happy to serve as guinea pigs for all sorts of new spacesuit technology.
See you the second time.
Today, Pascal Lee is trying out a voice recognition system that's designed to let astronauts control all their spacesuit computers. Before starting the test, Pascal must train the system to recognize the way his voice sounds inside the spacesuit bubble.
How's your airflow?
Very good.
Good.
The training involves reading a passage from the classic book Treasure Island.
I remember him as if it were yesterday.
As Pascal speaks, the computer stores voice prints for each word or sound he utters.
Yo ho ho and a bottle of rum.
Basically the black all the way around the
A
screen.
tiny computer display is mounted on Pascal's glasses once the voice training is over.
Why don't you do a little exploring and we'll take some dictation.
Do a little exploring and we'll take some dictation. Rocks on a slope. Angular gravel. Debris apron. The idea here is that when you're exploring on Mars, you don't have your hands available to take notes. And so we're experimenting with this concept whereby we would explore and dictate our observations, our comments. Rock formation, similar to that of Fortress, and also similar to that on Haynes Ridge. Many small coral forms. The trouble, of course, we're running into right now is that this voice recognition software is not able yet to pick up all the words. Houston, we have an interface problem. It's going to be an iterative process. This is how engineering works. You try and you fail, and you try and you fail, and you try and you fail, and then one day you try and it works.
I can give you a hard reboot.
It will take years of additional research and $100 million or more until we have a suit that's ready for Mars. The spacesuit work going on at NASA Base Camp is a good start. But over near the crater at the Mars Society habitat, they needed suits this year. And they only had about $1,000 to spend on each one.
What we have here is the pile of spacesuits and helmets that we used on an EVA yesterday. These, of course, for now are not real spacesuits, but they are very nice simulated spacesuits designed by volunteers of the Mars Society. You have the spacesuit itself. You enter it from the rear. You have the backpack with the neck ring. And the backpack contains fans that provide air into the helmet that you wear. And this helmet was designed by the volunteers, ingenious volunteers I should add, of the Mars Society, because look at this. This was once a trash can lid. And then of course we have our simulated EVA gloves. This is a headset that will allow you to communicate with your buddy when you are on an EVA. There are two main reasons why we want to go through the process of wearing a dummy spacesuit, if you will, in doing our field work, as opposed to just going out there and doing it in normal shirt sleeve. This spacesuit is not that easy to put on. It's got many moving parts, and that delays your operations. How much time will it take? What impact will it have on your activities? In other words, you can't just go outside on Mars like you are here on Earth. Not only are you inside a suit, but the suit doesn't allow you to see every part of your body. It doesn't allow you to see every part of the external environment. There is a constricting factor that's built into the suit that makes it somewhat bulky and uncomfortable. And while it's not what a real suit would really feel like, it will limit the amount of fieldwork we can do. I think there's a very positive and I would say modest message in the fact that we're wearing spacesuits. We're not playing astronauts or pretending we are quite ready to go at this point. This is just part of learning how to do it right.
The story of how the Mars Society's habitat got to the Arctic begins in Denver, Colorado, where the simulated fiberglass spaceship, funded by Discovery Channel, Flashline.com, and others, was designed and first constructed early in the year 2000. Leading the project is Dr. Robert Zubrin, the outspoken president of the Mars Society. In his normal life, Zubrin is an aerospace engineer who spends much of his time developing affordable ideas for getting humans to Mars.
So, are we going to be good to fly tomorrow?
Yep, we'll make it fit.
His inventions include a machine that can turn the Martian carbon dioxide atmosphere into rocket fuel, and a life support backpack that could make unlimited oxygen from the thin Martian air. Zubrin's passion for seeing humans go to Mars someday led him and the Mars Society to construct the simulated spaceship. The idea was to land it where it could help expand the Mars research NASA was already conducting. But getting it up to the Arctic was no easy feat.
When it came time to see how we could help the Mars Society ship parts for the habitat up to the Arctic, I looked to the Marines for help. The Marines were able to successfully deliver the bulk and the most important components of the habitat.
You got to figure that the C-130 is rolling by about 150 knots, and pulling those chutes out with the size of the load and with these winds, bringing it down in this kind of area is a real challenge.
A paradrop is always an adventure. You are, after all, throwing something out the door of an airplane and hoping that it will be successfully delivered to the ground while using a parachute that is meant to bring it down quickly. Number 1 went well, number 2 went well, number 3 went well. One load drifted a little bit in the wind and landed on the slope, but all the parts were safe.
Roger, we're continuing 15 to 20 knots at 015.
With the winds right now, we're kind of pushing the limit. We're about 15 knots, and we got a limit of about 17.
Standing over there, I saw it roll when it hit the ground. I really had some doubts coming over here. I thought I was going to see something really ugly, but it looks pretty good.
This was a very successful delivery until we got to the very last paradrop of that day, paradrop number 7. My immediate reaction was, uh-oh.
The 7th paradrop was a total disaster. The payload separated from the chute at an altitude of 1,000 feet and it crashed into the ground at several hundred miles an hour, completely destroying the floors for the habitat, the fiberglass floors, the trailer that we had shipped to the Arctic in order to be able to move things that we thought might land wide, and the crane that was needed to erect the heavy and big habitat walls was destroyed. I got on the phone. I started calling all over Canada to try to locate alternative resources. I looked into everything. I looked into using helicopters.
Trying to make a fix in the field and trying to rush and to try to force things is going to just make things worse. And eventually somebody will get maimed or killed.
I'm not here to push you guys to do anything. Okay? I'm just here to hear you guys tell me what in your professional opinions is possible for the season or not possible.
The construction team decides to postpone building the habitat until the next summer. They clean up the debris and purchase tickets to leave from the nearest airport, 200 miles away on another island.
When I got off the plane in Resolute last year, the situation here was really grim. I was greeted directly at the airport by the leader of the first construction crew who handed me an ultimatum. They weren't committed to the project. It wasn't important to them. It was just a job. At the first sign of adversity, they were willing to quit.
I'm finished talking about it. I am so irritated with the things that you said in your email, that you had the audacity to say the things that you did. I'm not quitting. Yes, because you're trying to go.